on problem 5, we have to find a positive and negative coterminal angle with 5 pi over 3. So one thing to note here is 6 pi over 3, since it each equals 2 pi when you reduce it, that's actually a full rotation. So 5 pi over 3 would be about this much. That's 5 pi over 3. If you go another pi over 3, you'd be at 6 pi over 3, and that would be 2 pi, a full rotation. So if we're right here and we add another 6 pi over 3, in other words, we add another 2 pi, we'd be at 11 pi over 3. And 11 pi over 3 would be like going around another time, and you would be coterminal. So that's our first answer in radians. If we go the other way, if we're at 5 pi over 3 and we go this way, 6 pi over 3, in other words, we go this way 2 pi units, you'd be at negative pi over 3. It'd be equivalent to starting here and you go negative pi over 3. So both of these are coterminal. 5 pi over 3, if you convert to degrees, so if you multiply this by 180 over pi, the pi's would cancel, and you end up with, it's 300 degrees. So to get coterminal angles with 300 degrees, we can add 360 degrees. That gives us 660 degrees, which is equivalent to 11 pi over 3. Or if you take your 300 degrees and instead subtract 360 degrees from it, you get negative 60 degrees. And that's the negative pi over 3. On the next problem, we're going to use the point negative 1, negative 2 to be on the terminal side at angle theta in standard position, and we'll evaluate the 6 trigonometric functions from that. So negative 1, negative 2 would be about right here. So the angle we're interested in is this. This is theta, that angle. But what's interesting is the coordinates of this point are negative 1, negative 2. If we draw a right triangle and we realize that these coordinates actually tell us the side lengths, here's what we find. If the y coordinate is negative 2, that means this side must be 2, since we've dropped 2 down from the x-axis. If the x coordinate's negative 1, that means we're 1 unit over, so this must be 1. So knowing this is a right triangle, we could figure out what the hypotenuse is. 1 squared plus 2 squared would have to equal the hypotenuse squared here. So 1 squared, this would be 5. So this hypotenuse here would have to be rad 5. We actually don't call this a hypotenuse in this case, we call it the radius. So I'm going to change my h to an r there. So the radius is rad 5. Now here's what we have. X is negative 1, y is negative 2, and the radius is rad 5. Using our circle definitions for trigonometric functions, for example, we know sine theta is y over r. So in this case, it's negative 2 over rad 5, which after we rationalize is negative 2 rad 5 over 5. Cosine of theta is going to be x over r, so it's, after rationalizing, going to be negative rad 5 over 2. Tangent is y over r, so it's negative 2 over negative 1, so it's 2. And then the reciprocal functions. Cosecant theta is going to be the reciprocal of this, so it will be negative rad 5 over 2. Secant theta is the reciprocal of this, which after we rationalize will be negative rad 5. And the reciprocal of 2 would be 1/2. On this next one, we have to evaluate negative 120 without a calculator. Negative 120 degrees, so if we start here and rotate down to this first axis, that's negative 90. Going another 30 degrees would get us to negative 120. The reference angle here is 60 degrees. And the reference angle is always drawn to the x-axis. So the angle between this and this is 60 degrees. We know that because if we're already at 120 degrees, we'd need another 60 to get to the 180. If we complete this triangle, we see it's a 30, 60, 90 triangle. And the length of this side would be rad 3, the length of this side would be 1, and the radius here would be 2. That's from properties of 30, 60, 90 triangles. So the coordinates of this point would be negative 1, negative rad 3. Now we know that sine theta is y over r. So the y coordinate is negative rad 3. And the radius is 2. So sine of negative 120 is negative rad 3 over 2. To find cosine without a calculator, well, we're doing something different here. This is inverse cosine of 1/2. So with inverse cosine, you're given the ratio of the sides and you're trying to find the angle. So what this is asking is, what angle does cosine produce 1/2 for? I recognize this 1 and this 2 from the 30, 60, 90 triangle. On a 30, 60, 90 triangle, the short side is 1, the hypotenuse is 2, and the long leg is rad 3. So since cosine is adjacent over hypotenuse, we need to find the angle that has an adjacent side of 1 and a hypotenuse of 2. 60 degrees has an adjacent side of 1 and a hypotenuse of 2. So our answer is 60 degrees.